couple of examples have some old IB exam questions. We're going to look at them. This one, whenever you have a derivative with sine, cos, or tan, you might want to take the time to write the power outside. It just helps you see the chain rule better. Because now if we look at this function and say, what's our outside function? Our outside function is the power of 4. So when I go to do the derivative, the chain rule says do your outside function first. Well, the derivative of a power, I have to move things over here a little bit. The derivative of a power, bring the number in front, subtract 1 from the exponent, the inside stays the same. And then the chain rule says, then do the derivative of the inside. Now, when I do the derivative of the inside, which is tan 2x, it's another chain rule. Because again, we have a 2x inside of a tan. Now my outside function is tan. The derivative of tan is secant squared, keep the inside the same, and then multiply by the inside of that. So it ends up being like a double chain rule. Chain rule, like I said, we wrote this down earlier, but in words, we do the derivative of the outside function, keep the inside function the same, then do the derivative of the inside function. In this case, I did that first. Derivative of the outside function, 4 came in front, subtract 1 from the exponent, kept the inside the same. But when I had to do the derivative of that inside function, it was another chain rule. So you follow the chain rules again. Like you could make a question that has a chain rule inside of 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 a chain rule over and over and over and over and over again. And it'll just be super long. But as long as you just keep the process the same, you should be fine. All right. Given h of x is x minus 2 over x minus 1 squared, where x doesn't equal 1, find h prime in this form. So unlike other questions so far, where you just have to find the derivative and leave it, this one's going to involve some simplification because we need to have it in that form in the end. So when I do the derivative, keep the bottom the same, derivative of the top minus keep the top the same, derivative of the bottom, all over the bottom squared. Now on the bottom, you can see that we have x minus 1 to the 4. So this is good in the fact that the form that we wanted x minus 1 to the something. So this is good because the form is good. However, the top's form is not good yet. Can you see on the top, you basically have two terms, this minus this. Okay? And if you look at those two terms, can you see that they have an x minus 1 in common? Okay? Factoring out a common factor is very helpful in calculus for simplifying. So noticing that those two terms in the top have an x minus 1 as a factor, and the fact that I have x minus 1s in my denominator, I'm going to factor out that x minus 1. What would be left in my first term? Another x minus 1. What would be left in my second term? A 2 and an x minus 2. But this will allow me to simplify one of these and one of those. In my numerator now, if I distribute and combine my like terms, I'm going to have positive 4 minus 1, which will be 3, minus x, and it is in the form that we were looking for. We could say that the a value would be 3 and the n value would be 3 as well, according to the form they were looking for at the beginning. Example 4. Suppose f of x equals 2 sine cube minus 3 sine x. Show that f prime of x equals negative 3 cos x cos 2x. So again, this instruction in the IB curriculum means it's like a mini identity. You start with something, you have to end with something else. Okay, we start with f of x. We want to end with f prime of x equaling. So we'll start by finding f prime of x. We have a chain rule. The 3 would come out in front, subtract 1 from the exponent, and then the derivative of the inside function, the derivative of sine, is cos minus 3 cos of x. Now, what I want you to see in this question that's very helpful in a show that question. Often what you want to show gives you hints for what you should do next. So in this case, I'm looking at negative 3 cos x cos 2x. I'm looking at my equation. I have no cos 2x's whatsoever. But I do have a negative 3 cos x. I have a negative 3 cos x here. This one is all multiplying. This one is adding and subtracting. So at this point, because I have this negative 3 cos x, I look at my equation and say, I'm going to factor out a negative 3 cos x out of this. I don't know if that's going to be helpful at this point, but this is often what happens when you're doing a proof. You're not sure where you're going, but you try something and see what happens. By doing this, by factoring this negative 3 cos x, I'm hoping that there's going to be something I can do in the brackets that gets me to that cos 2x. I'm going to just be that much closer. So I factor out the negative 3 cos x, and I'm left with a negative 2 sine squared plus 1. And then you're like, oh, that might be one of my identities. Is 1 minus 2 sine squared x equal to cos 2x? It is. So those are on your formula sheet as well. And you will have shown what you wanted to show. Yes? Why isn't this all over negative 3 cos x? Out of here, I took out a negative 3, giving me a negative 2, right? Because negative 3 times negative 2 is 6. And I took out the cos x, leaving me with just the sine squared. Some other IB instructions. In math, have you ever come across the IB instruction? Have we ever talked about hence or otherwise yet? These are IB command words. No? Have you never seen a hence? We haven't done a hence or otherwise question yet, or have we? Don't think so? Okay. So if the square root of x this, show that, so that underline means that we have to do a little mini proof. And then the hence or otherwise means that they're giving you a hint you should really use your solution to do the next part. If it just says hence, you have to use your solution to the next part. But if it says hence or otherwise, you're still allowed to do something else. But it's telling you the best thing to do is use what you just figured out. So in this case, again, we know what y is. I'm going to just take the time to change the square root to x to the half. Finding the derivative, it's a product rule, so keep one the same. Derivative of the second one. Can you see that this second one is a chain rule? There is a derivative inside, because the derivative of negative x would be negative 1. Plus, keep the second one the same, derivative of the first one. So there's our preliminary work, just finding the derivative. Does that look at all what we wanted to show it as? No. So what do we notice in the answer? The answer has square roots back again. So I'm going to take the time here and change that back to a square root. 2 times 3 minus, negative 2 times 3 minus x plus 3 minus x all squared over 2 root x. Okay? Again, in a show that question, look at what you want to show to tell you ideas for what you should do. My final answer is a single fraction with a denominator of 2 root x. If I wanted to get a single fraction with these, I would need a common denominator. So I'm going to take this first term, which is all over 1 right now, and multiply it by 2 root x and 2 root x to get a common denominator. What happens when I get that common denominator of 2 root x? Well, here I'm going to get 2 times negative 2, negative 4. What's root x times root x? Just x. 3 minus x plus 3 minus x squared. Now in the top, again, looking back to what we want 3 minus x times 3 minus 5x. We have a bunch of other stuff right now. You have 2 options, okay? I will tell you what you will want to do, and then I'll show you the easier option, okay? What you will want to do, which isn't bad, is expand everything out, combine your like terms, and then factor. That's not bad. But, again, just like the previous question, do you notice that we have 2 terms? And do you notice that there's a factor already in common in those 2 terms? There's a 3 minus x in both of them. If you can see that, you'll make your mathematics go faster, because if I factor a 3 minus x out, what am I left with in my first term? Just a negative 4x, and I'm left with another 3 minus x. And simplifying this, this becomes 3 minus 5x. I sure hope that's what we wanted to show. Yes. And then part B, or the second part, the hence part, find where the tangent is horizontal. Well, what do we have to have for a horizontal tangent? We need a slope of 0. If I make my slope 0, so this is why the hence it says use the answer you have. Okay, my slope is 0. This is what I have. And it's really easy to solve for. Because the only time a fraction is equal to 0 is if your numerator is equal to 0. Technically, you could multiply both sides by 2 root x. And you see that your 2 root x would just go away. And basically, you're just solving when is this equal to 0. Okay? Now, in the stress of an exam, you might get all stressed out. You might expand that, recognize it's a quadratic equation, and realize you have to factor it, which it's already done for us. So where are our solutions? X could be 3. X could be 3/5. One more example. If x squared minus 3x plus 1 over x plus 2 show that, hence find all the values of x where the derivative is undefined. What kind of rule are we going to use for the derivative here? The quotient rule. Glad no one said guess and check. I don't know how you would guess and check with derivatives. Oh, I think it might be this. I don't know, flip to the back of the book. Nope. Guess again. So our derivative with the quotient rule, keep the bottom the same. Derivative of the top minus keep the top the same. Derivative of the bottom over the bottom squared. As far as looking at what we want to show, the bottom's already the same. And so it looks like all we need to do is get the top to look the same. There's nothing to factor on the top, but it looks like our best bet is just to multiply everything out and simplify. So if I distribute here, I'm going to get 2x squared plus x minus 6 minus x squared minus 3x plus 1 over x plus 2 squared, 2x squared. Combine our like terms. 2x squared minus x squared is x squared. X minus a negative 3x will be plus 4x. Negative 6 minus a 1, negative 7. So that showed that one was really quite straightforward. No fancy math necessary. It says this time hence. Hence means we have to use the result we found. Okay? It's asking when it's undefined, right? Can't divide by 0. So x can't equal negative 2. That would be our non-permissible value when the derivative is undefined.